In this hands-on, we're going to explore Python's specialized container data types, focusing on some real-world applications such as streaming log processing, genome pattern recognition, and stock price anomaly detection, as we have in other hands-ons. In genome pattern recognition, managing and accessing gene data efficiently is crucial. Python's named tuple from the collections module is a lightweight, immutable data type that provides a way to create tuple-like objects with named fields. And this enhances the code's readability and structure. If you take a look at this snippet here, it exemplifies what we're talking about now. Here we define a named tuple called gene with fields name, function, and location. This allows us to represent a gene with clear, readable attributes. For example, when we create an instance of gene with specific details like BRCA1, DNA repair for function, and chromosome 17 for location, we can access these attributes with dot notation, just like attributes of a class, but with the immutability and memory efficiency benefits of a tuple. Moving on to Deques or double-ended queues for streaming log processing. Deques or double-ended queues support thread-safe, memory-efficient appends and pops from either side of the deck. So here's an example snippet to illustrate what we're talking about. In scenarios like streaming log processing, for instance, where you need to handle data coming in and going out in a time-efficient manner, Deques are ideal. For instance, when managing a stream of log entries, as we're simulating over here, you can append new logs at one end and process or remove older logs from the other end. This functionality makes Deques perfect for queue-like data structures where both ends are utilized but need to be done so in a time and memory-efficient manner. Next, we move on to ChainMap for stock price anomaly detection. In this context, managing algorithm parameters is key in the context of stock price anomaly detection, Here, Python's ChainMap comes into the picture. A chain map groups multiple dictionaries into a single view, making it perfect for scenarios where you need to manage default and custom settings. So let's take a look at this snippet and its output while we're talking through this. Here we have default algorithm parameters and some user-defined parameters. By using a chain map, as we are on this line, we can create a single view that gives precedence to user-defined parameters by placing them at the beginning of the chain map, while falling back on the defaults where necessary. This feature is invaluable, hence, in settings where configurations need to be flexible and adaptable. Next, let's move on to counter for our example of DNA sequence frequency analysis. In genome studies, for instance, counting the frequency of DNA sequences is a common task. Counter simplifies this by taking an iterable, like a list of DNA sequences, and returning a dictionary with elements as keys and their counts as values. This is quite a convenient and efficient way to perform frequency analysis on data, with two important values returned to you with singular operations. Let's move on to OrderedDict for maintaining ordered stock price updates in our example here. In financial analysis, the sequence of events can be as important as the events themselves. Python's OrderedDict, also from the collections module, remembers the order in which keys were first inserted. So if we take a look at this code snippet now to follow along with what we're discussing, if you're tracking stock price updates, as we are here with Apple, Google, and Microsoft, for instance, maintaining their order of occurrence is crucial in finance. OrderedDict allows you to preserve this order, ensuring that any analysis reflects the sequence of events that happened. Moving further on into defaultDict for organizing logs in this example, defaultDict is a subclass of the built-in dict or dictionary that initializes keys with a default value if they are not yet present. So if we take a look at this snippet as we talk through here, in log processing, we'll often categorize log messages, such as info, error, info, warning, followed by the message content itself. With defaultDict, what you can do is automatically initialize lists for each new log category, streamlining the process of log categorization and reducing the amount of boilerplate code that's required to manage all of this. In conclusion, Python's specialized container data types offer a powerful, efficient, and quite an elegant way for various real-world applications.